This Fireside Conversation is with Bruno Ciscato. Bruno is a board member of SBI R3 Japan, and he's also responsible for strategic enterprise relationships at R3 out of his London office. R3 is a technology firm that has created CORDA, a leading blockchain technology, a permissioned distributed ledger technology focused on the financial sector. Bruno, over the past 20 years, or 30 years actually, has been able to stay at the epicenter of several technological revolutions, starting with the internet and now also with blockchain technology. In his role at R3, he's involved in a broad area of blockchain-enabled business models and use cases that go far beyond cryptocurrencies. I've had the privilege of working with Bruno in the context of Exedras, a startup that uses blockchain technology in the precious metals industry that we founded in 2017. The conversations with Bruno are always extremely interesting and long. That's why this conversation we've actually done in two parts. The first part will be a bit more basic and will be focused on the basics of blockchain and also on the background of Bruno, which has had a very interesting and unique career. The second part then will be focused on use cases of blockchain, use cases that, like I said, go far beyond cryptocurrency. Cryptocurrencies obviously are in the news currently, and because of the spotlight being on cryptocurrencies that in general are not that interesting use cases, most of them are not that great or not great at all. There's a lot of use cases for blockchain beyond cryptocurrencies, and that's what we'll focus on in the second part. As a bit of a notice, we are on Spotify as well at this point. So, you can not just watch, but you can also listen to this conversation. I hope you enjoy it. So, Bruno, welcome to Edmatingen. It's really great to have you here. I think I have to give out a little bit of a warning to our viewers because this could be a long conversation. Every time we talk, it's just there's so much to discuss, and I really look forward to this. And we'll cover a few different areas like we discussed, starting kind of with more basic things about crypto, but then also going more deeply into blockchain technology, into use cases. But first, let's hear a bit more about your background.
Yes.
Because it's really interesting also how you very early and then more and more went into technology.
So, yeah, absolutely. So first of all, thank you for having me. It's always a pleasure. And yes, I always enjoy my conversations with Frank. So I think we'll have quite a bit to cover today. And so it all started in the late 90s with the internet. I really saw the potential. And I got hooked, and I said, okay, this is kind of important. It's going to be big. It's going to change society. And it's one of the few predictions that I got right in my... So I got that one right. And so I got into technology. But again, for me, it wasn't really just technology. It was the potential of the potential impact of the technology on society, which has been a common thread throughout my career.
You before that, did you study technology, or what? How did you get into technology after going to school, and maybe even starting with where did you grow up in Italy? I think I can hear that.
Yeah, absolutely. Yes. So I grew up in Florence, which is a beautiful place. Yeah. So I'm very fortunate. And then I actually did. I have a PhD in geology.
Geology.
Yes, geology. Okay. So I'm an expert in ocean floor spreading, which is kind of a niche topic.
Ocean floor spreading.
Yeah, that's what happens like in the middle of the Atlantic Ocean, where there is that big crack, and the two plates, the European plate and the American plate, are pulled apart, and there is new crust that's being created by volcanic eruptions. So anyways, that is my background. And
were you a diver then, or did you
no,
did you spend time in the ocean? Or
no,
did you?
actually, that is quite expensive. So the trick is that if you don't have that much money, if you are not in a large institutions that has a lot of funding to actually go with a ship and do what you just said, what you do, you go to places like in mountain ranges where some bits of oceanic crust have been caught up in mountain building events. So imagine like when India smashed into Asia and the Himalaya was created. The bit of ocean between India and Asia was squeezed into that mountain in between those two plates. And now you find bits and pieces of that ancient oceanic crust up in the mountains, which gives you a big advantage because now you can actually walk with your geologist hammer over like oceanic crust, and then you can pick up pieces of rock and then you can study them in the lab. So it's
how did the Alps? I mean, the Alps also at some point.
Yes.
But do you see oceanic crust in the Alps as well?
Yes, it's all. If you think about the Alps and then Greece and Turkey, Iran, the Himalayas.
It's all the same.
Yeah, it's all the same. It's like a big scar. I mean, and there are bits and pieces of oceanic crust, which took me to the US, and this is relevant for the following like part of the story. And that was 1993. So when I got there was a big computer sitting on a corner of my advisor room, and I asked, "What is that?" "Oh, it's a Unix box, and we don't know how to use it, and it's connected to the internet, and you can do stuff with it." And no one knew what to do with it.
What kind of stuff was the question?
So can I try it? So I got an account, I started playing with it, and then I created some software that I needed to do, like a stress inversion, which is a complicated thing that you do when you have to do what I was doing, which is you study all the oceanic crust. The problem with that is that it's been like squeezed in these, like with these mountain buildings events, that oceanic crust, which originally was like flat, was the bottom of the ocean, get crumpled like a piece of paper and then gets torn apart. And then it gets it ends up being upside down. And so you have to kind of unravel all those episodes of like deformation so that you can recreate a mental picture of the original oceanic crust.
That's over millions of years.
Yes,
probably,
yes.
Right?
So I was writing computer software for doing that based on the data that I was collecting in the field.
So computer simulation to some degree.
Yes, that kind of stuff.
Okay.
So a year later, when I went back to Italy, to Florence, I didn't have any of that. So I called the computer science department and I said, I need a Unix account because I need to finish my work. And they said, no way. And then the other thing is that the big news was that we finally had the internet in the geology department as well. But the internet was just a hole in the wall where you were supposed to plug your computer and connect it to the internet. But of course, no one knew how to do that. So I said, oh, damn, what am I going to do about this? So I started doing a bit of research, which was really hard because this is before the internet. Back in the day, you couldn't just Google it. How do I connect my computer to the internet? It didn't work that way because there wasn't.
This was like 95?
94. So eventually I managed to come across Linux, which was a free open source version of the Unix operating system. I managed to download it on a computer. I managed to connect it to the internet. And then I saw that it was working. So I decided to start handing out Unix accounts to my friends. And then, so I became an expert in these things, and I got very excited.
Basically, to continue your research,
yes,
you kind of went deep and did it yourself instead of having them kind of provide it to you.
Yes, exactly. I rolled up my sleeves. I did it myself,
cool.
And then a company got interested in what I was doing, and then I became the CTO of one of the first internet service providers in Italy.
What was the name of that?
It was FlashNet, which had a very good reputation. It was based out of Rome. So I relocated to Rome. And so, again, I'm really spoiled because after growing up in Florence and this brief stint in the United States, I went to Rome, where I lived for 15 years, and then I moved to London about 10 years ago.
Yeah, Florence and Rome are definitely two beautiful places. Yeah. Growing up in Florence, I mean, it's and then studying geology. How much of that was triggered by, you know, I assume, you know, growing up in Florence with all that history and culture and art, was that what triggered your interest in the past, or how did that come about?
No, it's another of these like random things that I've done in my life. So when I was 20, I went to Nepal with a friend of mine, so just the two of us. And we didn't have anything. We didn't even have a guidebook. We only had an address written on a small piece of paper of an hotel in Kathmandu. And again, it was like 86. So in 86, I mean, when you were out there, you were totally disconnected from your world. You couldn't call home. I mean, you could, but it was very complicated, very expensive. So anyways, we went there and we crossed the Himalayas on foot. It was amazing. So
from Kathmandu, where did you go?
From Kathmandu, we went to Pokhara, which is west of Kathmandu, and then from there we started hiking, and we went across the Himalayas on the other side. In Mustang, we went to Jomson.
To where?
Jomson, which is a tiny village on the other side of the Himalayas.
Okay.
So we went in between Annapurna, I believe, and Dhaulagiri. Yeah. So these are two 8,000 meters and plus mountains, and we went to the other side.
You hiked that? All of that?
Yes.
How long were you hiking?
For a couple of weeks.
It's only 2 weeks.
Yes.
It sounds like it's really
south
far.
to north, and we crossed the Himalayas. Okay. So, and I fell in love with the whole thing. So when I went back, I signed up for a geology degree. Yeah.
That explains it. So basically you went from geology, you kind of came into information technology more and more. And what was your next step after that?
And then I stayed, in that space for, ever since, because again, internet, I really saw the potential. I remember around the year 2000 when there was a lot of talking about the new economy. I don't know if you remember that, and then the bubble burst. And I remember even then I kept telling people, look guys, it's not about the economy. The economy is the same. I mean, the basic mechanisms are the same. This is about a different society. I saw that this would have had a big impact on all aspects of how we live. It wasn't just like a new economy.
Right.
Now I feel like with blockchain, we have come across a technology that can have a similar impact on society.
Absolutely. Before we move more into that, Bruno, though, I'd like to step back one more time and explain a bit where you are now, because that's important for the context also. You are in the management of a company called R3, and you're focused on a blockchain protocol called CORDA. And I think it's important that maybe before we go into some of these other discussions that we kind of explain what CORDA does, and also maybe just for some viewers also help them a bit to understand what blockchain really is, and particularly what blockchain is beyond crypto. Because right now everyone's talking about cryptocurrency, but there's lots of use cases of blockchain which have nothing to do with the exchange of currency necessarily. It's there are many others, and at CORDA you have a lot of those use cases, so it's going to be very interesting to look at some of those. But maybe first, CORDA, you've been there now for how long? For 4 years? Or
almost 4 years.
Almost 4 years. Yeah.
Yes, no, absolutely. And so R3 is a company that was born as a consortium of banks initially. Now it's an enterprise software company.
How many banks? It's like a lot of banks. I looked at the list, and there's like the who is who of banking is involved in CORDA, and CORDA is something that most people don't hear that much about usually.
So initially, when there was a lot of interest in back in the day, in the early stages, so a number of banks, like you said, the who's who of the world banking system, got together and they participated in this consortium. Now, like I said, over time we have morphed into a proper enterprise software company. But the reason why so many banks got together is because, again, an innovation in that space can have such a fundamental impact on how society works at a fundamental level that they really wanted to understand and not be left behind.
What it says on your website, it says R3's CORDA is the world's leading private, permissioned, distributed ledger, smart workflow, and tokenization platform, powering digital finance. And if you look at the use cases, it's quite broad, from CBDC to exchanges like SIX exchange and so on. So CORDA has made huge inroads in a big part of the financial sphere.
Yeah, absolutely. So in order to understand, so thanks for that like the definition that you put up from the web. That's a mouthful. So in order to fully understand,
it is a mouthful.
In order to understand what that means, maybe we need to go back to basics and understand what blockchain is. And you also mentioned crypto. So it all started with blockchain. It all started with Bitcoin. Okay. And Bitcoin was, let's say, the Bitcoin white paper was published in 2009 or late 2008. But anyways, the first transaction was in early 2009. And so blockchain is the technology that underpins Bitcoin. So it wasn't like the inventor of blockchain came up with an idea, I need to have this technology. He had or she, or maybe was an entity, because that's also an interesting story. We don't know who the inventor was. Had a problem to solve, and then they created blockchain as a solution to solve that problem. And what the creator were trying to do was to create electronic cash. That is what Bitcoin is.
So the fundamental, the fundamental thing in my view of cash is really the exchange, right? What you're doing is you're stopping, or you're moving from a barter system where I give you a chicken and you give me eggs. Maybe that would not be the best trade, but what you're doing basically is you're now exchanging the chicken for cash. And doing it electronically is what Bitcoin is, kind of the use case of Bitcoin. But as far as the technology goes, for me, it's still Bitcoin. When I understand it, it's really the key thing about it is really this distributed ledger approach, right? And the synchronization and the encryption of the information. Because digital cash per se, I think, existed already before crypto or before Bitcoin.
And that's one of the misconceptions that we need to correct. One big source of confusion is that people mix up in their minds cash with payments. So a lot of the good stuff that we have is payments. That has nothing to do with it. It's different from cash. Payments is become very simple, super efficient. I mean, I use my phone. I don't even need to pull out my debit card anymore. I can just tap my phone. But it is not cash. That is payment systems. So sometimes people say, why do we need CBDC? Why do we need these alternative forms of payments? Because they're not alternative forms of payments. They're alternative forms of cash. And cash is different. So the reason why it didn't exist before, it is because it was impossible to give this electronic version the same attributes of the physical version, which is, for example, instantaneous settlement, finality. I give you my note and it's yours. Unless I chase you, I try to get it back. I mean, it's done. We are done. We don't need to wait like settlements. And then it's also anonymous, which is very powerful. And these are ramifications for if we want to get into that space and talk about society. But so it was impossible to do it electronically because you would always leave a trail which would allow to be identified, or maybe the settlement wasn't instantaneous. I mean, the things I've just described, like being anonymous, being settled instantaneously, can be seen as positive attributes or negative attributes, depending on the context. If you're fighting organized crime, being anonymous is not like a positive attribute of cash. If you live in a society where there is less restrictions on liberties, then you understand that, well, actually, if we only have payments, we don't have cash anymore, and I'm cut off the payment systems, I can be no longer a functioning member of society. So it is important that actually I can fall back to cash. And instead of using my cards, I can use like notes, and I can pay with notes.
So what you're saying is that digital or electronic cash or payment systems are completely dependent on the centralized structures of the banking system that currently has been built over many years. And that banking system is something which is highly regulated, highly controlled, and could be shut off. So it's not cash in a sense that you own that cash. You're always dependent on that payment system being run by a third party. And I'm just trying to paraphrase to make sure I understand, is that Bitcoin to some degree has now created a situation where you and I can transact, but not with a piece of paper, but with a piece of electric cash or a piece of digital data, basically. And there that allows us to move value or exchange goods without having to use the banking system. And that's that loss of control. And that's, I guess, where a lot of the stigma comes from, or a lot of the resistance also from governments and central banks, because they are losing control of the money system to some degree.
Exactly. That is what I believe spurred the central banks to action, because they saw it as a potential threat, and they thought, well, okay, we need to understand that space. We need to understand what is going on, because people trust. It's a matter of trust. They trust the money that is printed by the central bank to always be accepted, always being redeemable, and that if people started trusting a different form of cash, then of course that creates a big problem for governments and sovereign states.
And one of the questions that always comes is, how can I trust a system that I actually don't know how it works? And I sometimes then have to smile internally, at least, because most people don't understand how the fractional reserve banking system works either, and how those IT systems work either. So it's a false pretense to say that we actually know how things work in the existing infrastructure. It's just that, like you said, we've gotten used to it over many years, and we now trust it. And there's been for many years a high level of trust, and rightfully so, in most of our governments. I mean, in Switzerland, I think it's justified to have a high level of trust in your government. However, history also teaches you that over time things can change, and so that trust could also be disappointed at some point. And so, but that's a whole philosophical topic. What I'd still like to get back to, Bruno, can you explain, for me, the Bitcoin, what it's all about is that distributed ledger technology. So basically it's different nodes. You and I have a node to some degree, or have a computer, and there's an algorithmic, a software way of our information being synchronized in order to make sure that there's a transfer of title, that a settlement is closed properly, and that you and I can't cheat, and that the value, the Bitcoin actually flows for whatever, if I bought something from you, then, I would send you that information, basically, that block of information. That's kind of how it works. And can you explain that in a better way? And also then explain, what is the difference of Bitcoin technology, for example, to what CORDA does? Because that's, to me, that's a key element of what you guys do. Back when I learned about CORDA, for me was a big moment to say, wow, this is interesting. Because Bitcoin, to some degree, if you can program, if you're into IT, there's actually not that much confidentiality and privacy, right? Because you actually have that information, and it's the complete set of information, which creates all kinds of problems around Bitcoin with regard to mining's another topic, but in general, the performance of Bitcoin has been an issue.
Absolutely, and I think that yes, I can definitely explain that, and also you made a very important point about trust, because that is the fundamental problem that the underlying technology tries to solve. they wanted to get rid of the trusted intermediary. They said, no, we don't want to trust a central entity. We don't want to trust a central bank. We don't want to trust anyone because, again, we don't want to be cut off from a system. Because
they wanted to make it a transaction and a value exchange between two parties.
Yes.
And cut everything else out, the whole system.
So how do you do that? Because now you expose yourself to other bad players, which are not maybe like central intermediaries, but maybe are people that are trying to cheat the system. Right. So maybe I want to put in two transactions. One is I only have one Bitcoin, and I'm trying to give it to two people. So I put in two transactions. Who's gonna tell which one is the right one? The right one? So again, traditionally we have said, okay, you know what? There's one guy. We delegate the authority to that. One guy, one entity, and so that is the trusted intermediary. If we don't want that, then everyone has to participate and has to have a way to prove that the first transaction was the valid one, and everyone else has to agree on that vision of the world, of the facts. And so that's why what Bitcoin needed and was created for this was this what is called a consensus mechanism, where everyone agrees on, okay, we have this shared view of the history of the world, because I first gave you a Bitcoin, then you gave it to someone else, and this is being recorded on this ledger. So ledger is the fundamental word here. So the blockchain is a big ledger where all these transactions are recorded by multiple people.
So these are these blocks of information which are basically on the chain. And if there, let's say there was 1,000 participants, Brunos and Franks on that network, what you're saying is that basically you giving me one Bitcoin is then logged on the ledger across all of these participants.
Yes.
So the information goes, in what form does that information go out?
So I'm literally sending out like a tiny file that only has that transaction and giving one Bitcoin to Frank that gets broadcasted to all the nodes, to use your term, that are participating, and all this computer that is doing this thing. And
it's a database,
yes,
basically.
Yes, exactly.
So basically what we have is, with those 1,000 participants, each one of them has their own ledger, in a sense, their own database. And we call it the distributed ledger because the ledger of each participant is synchronized with the databases of the other participants.
Yeah.
So all the information, in the case of Bitcoin, everyone has that information. In what form? Is it encrypted for everyone? So basically, would Serena, that is sitting over here, would she see that you gave me that one Bitcoin if she knows how to program?
So what she will see, it won't be my name and your name. She will see my Bitcoin, my wallet address,
your address,
and your wallet address.
Right.
And the difference with bank account numbers is that with Bitcoin, everyone can create a new, let's call it bank account number,
wallet
for every new transaction. Because you can create like
so you could have multiple wallets, but then you have to keep track of all the keys and everything.
Which is what people get wrong, and that's why it's a complicated technology to use. It's not user friendly. But if you do that, so there are two things at play here. So first of all, I'm creating the account number, and so since I'm creating it, I'm not providing my ID to anyone else. So people will see on the ledger that there is this account number where the money is coming from that goes into a different account number, but you can't make that association. In some cases, you can. If for some reasons, at a certain point in time, someone has been able to make that connection between that ID, with that number and myself, then I lose my anonymity. So it's kind of a thin veil of anonymity. It's not really anonymous. It's really...
It's not.
You can easily say crack that. And there are companies that are specializing in the forensic analysis of the ledger. Why? Because the ledger is public. Everyone can see it. You don't even need to sign up. You just connect the network. If you have the right software, you start getting these broadcast announcements of new transactions, And then if you want to participate, you can start adding those transactions to the ledger.
When I started looking into blockchain and Bitcoin in particular back in 2017, I really read a lot and read different white papers and so on. That was one of the things I didn't like so much, was the fact that there is not really privacy. And I was coming from an angle of, really looking for a use case where you could have more of a process or corporate re-engineering type use of blockchain. In my background, when I used to work with Accenture and then Price Waterhouse, we did large IT projects, and one of the things that for industry solutions or for large exchanges was an issue was always the aspect of having a centralized database, and that data potentially being abused and manipulated. That is something where originally I thought blockchain, that would be really interesting if you have a decentralized ledger and the database is no longer central, and therefore everyone owns their data. And at first I was a bit disillusioned because I thought when I looked at Bitcoin that would not be the case. And that's when I then actually stumbled across CORDA and some other protocols which very much allow you to spread ownership and control of data, but at the same time synchronize or organize the traffic according to certain rules. And so that was, for me, that was the moment when I really got interested in blockchain, because there was, beyond Bitcoin and cryptocurrency, I saw all kinds of potential applications that we could use. With Bitcoin, there's one aspect, and you just touched on it with mining, which I find extremely interesting when you compare it to the banking system, is also the limitation, right? The algorithm which creates a limitation, just like you would have it with gold. There's not a limitless amount of Bitcoin that can be created. And that has to do with the way you just described the mining as well.
Yes, so starting from the last one, it's very easy, yes. So there is the new Bitcoin, so that reward that I was talking about when you add a new page to the ledger is how new Bitcoins are created. So
right.
that reward that miners get is not like Bitcoins that are transferred from some other people to them. It's a new Bitcoin that is mined, is minted, let's say. And the way Bitcoin has been created, there is a cap on the amount of new Bitcoins that will be created over time, which is 21 million, about 21 million. And I think we should probably reach that number around the year 2000, it's going to be like in the mid next century, something about that. Anyways, and that's why people think, okay, this is great because this is not inflationary, because you can print more money, but then there are some misunderstanding connected to that vision, but we will get into that later. The other thing that you mentioned is the problem of the fact that this ledger is distributed. So if we go back for a moment, two things that we have described about Bitcoin and the distributed ledger is that these addresses are anonymous, and these transactions are broadcast to everyone. In some contexts, like financial markets, that is not good. It's not good because I want to know who's my counterparty. I can't just trust a random address. And the other thing why it's not good is that I don't want everyone to know about that. Exactly. I don't want to broadcast all those transactions, because if somehow, somewhere, that connection is made between that like anonymous ID and the real entity behind it, then that means that everyone will know what is happening. And whether we consider it a bad or a good thing, we know that in financial transactions, privacy is really important, because people take opposite sides of a deal because they believe in a different vision of the future, and they want to keep to themselves what they're doing, because otherwise they lose an edge against the competition. So that's where we come into the picture. We said, okay, you know what? With this new technology, we have realized how powerful it is if people can collaborate on keeping a set of facts up to date, shared, and that represents a single source of truth. But what we don't like is these two limitations. We don't like that it's fully or almost fully anonymous, and we don't like that everyone knows about this transaction. So our technology, which is CORDA, works in a slightly different way. So instead of broadcasting these transactions to all the participants, we only share these transactions to the parties to that transaction. So if I'm sharing, if I'm giving you something, whether it is a digital asset or is like a token, then only you and I will have that information in our like piece of this distributed ledger. But I also have information between on the transactions that I've shared with another party. So I have information about both those transactions, but you only have information about your transaction with me and your transactions with other people. But then all these different pieces all together represent this shared view of reality. The world, which is the reality.
You have that one slide that you showed at one of the events that we were at together with the Madonna, or was it Mona Lisa?
It was Mona Lisa by Leonardo da Vinci. Yes.
Yes. So going back to your days at Florence, you created that link, and basically that's a really good way. I don't know if you want to explain that briefly, because there you compare Bitcoin technology with the CORDA protocol.
Yes, there are two different ways of distributing the ledger. One way is what Bitcoin does, that it makes replicas of the same facts.
1,000 Mona Lisas.
And that gets distributed to all the participants. Right. So now that all this it is distributed, even if you try to, if you are a bad actor and you try to change one, all the others will not be touched. Then you can say, oh, actually 99% of the Mona Lisas are this, so that is like a bad apple. I'm going to disregard that copy. On the other side, we see what we are doing. So the way we distribute that ledger is that we take all these pieces of the puzzle, and you can think of one of those pieces are just like the transactions between you and myself. Then another piece of the puzzle can be the transactions between me and another entity. And then if you put all of them together, that represents the shared view of the world.
And the rules of the system, basically, which I think runs a lot via the governance and the notary node, I think is the terms that you guys use, make sure that the pieces of the puzzle in the end actually need to fit exactly. So those are the algorithms which actually create the pieces of the puzzle, and if a piece of the puzzle doesn't fit, then in that case that is the bad actor, or the situation where a transaction might not be good.
Yes, exactly. Okay. So that is one important thing that we do differently. So again, we preserve the power of having only one source of truth with a shared view of the world. And then the other thing is that instead of letting people use anonymous ID to represent their transactions, or themselves on the ledger, we do kind of a KYC, know your customer. So there is an onboarding process. If you want to participate in this business network, then we're going to check your identity. We also check entities against like embargo lists, or we really do a proper KYC process. And then if you pass that like onboarding process, you get assigned a certificate that represents your identity on the network.
So CORDA is really a tool that is used in permissioned networks, meaning that it's going to be, to some degree, will never be something which goes out to millions. It's always going to be something which is maybe more B2B oriented.
Exactly. Yes.
Okay. We'll get into Xedras a bit in other use cases, because that was really what really got me interested in the business case of Xedras, basically creating a system for the precious metals industry and ensuring that each participant, be it a refiner, be it a bank, be it a mine, be it a dealer or a logistics company, that they actually own their data, that piece of the Mona Lisa on their database. But at the same time, the system ensures that things happen and are logged and on the ledger according to certain rules. So that you can build that trust and you can build a system that works according to how the industry wants things to go. And that was kind of what started me on CORDA. Before, just one last thing I'd like to do. I don't know if you could, Bruno, if you could explain this a bit, because CORDA basically lives in this world where, when we look at digital assets, CORDA then can create a situation where you can trade these digital assets. And the origination, you talked about mining, but there's also the tokenization part.
Yes.
Can you explain that a bit? Or,
yes, absolutely. So once you have a system like this in place where you can represent, in our original case, cash on a ledger, so that it becomes electronic cash, then you can do it with other assets as well. So instead of representing like money, you can represent real estate, for example, and you can take property. You can create a digital ID of this project, or maybe a better way of thinking about it, you can create a digital twin of some real estate, and once you have the digital twin, you can put it on the ledger, and you can treat it as if it were a Bitcoin. So it's the technical term is a token, which comes from this analogy with real money. And so now what you can do also, which is even more powerful, is that instead of representing some real estate with just one token, you can actually use as many tokens as you want. So now you are securitizing that thing, which can be real estate, can be fine wine. We have a client in Japan, for example, that has built a digital asset platform for securitizing all sorts of assets. They've started with real estate, but over time, the plan is to move into, again, fine art, fine wine, whatever, even sneakers. And then people can buy fractions of these securitized assets. And the way you change ownership of these assets is very efficient, because you treat them as tokens on the ledger. So you can apply this technology to make more efficient the securitization of assets and the exchange of these securitized assets.
So the digital asset can be a cryptocurrency, but can also be something which has been around for a long time, a securitized value or asset, a company, a fund, a bottle of wine. And the difference really is, from securitization, really the difference is one of technology. It's that blockchain technology, and there's different protocols that you can use for that. Now, with FTX, and all the things in the news lately, which have been negative, is how can I trust? How do we get, people to trust in that kind of technology when things like FTX happen, where the actual exchange, was the problem? Yeah. Because now you want to trade that securitized asset, that token, and you want to use blockchain technology or non-banking system type exchanges, but we've had several instances now where things went bad. We also had the instances with some stable coins like Tether, where they were not really backed the way they said they were with dollars. How do you explain that to people?
Yeah, it's actually pretty simple, and I think that you raise an important point, because we need to clarify what's actually happened. Otherwise, people get confused. So. The important thing to understand is that what happened with FTX and maybe some other examples has nothing to do with the innovation that Bitcoin
it's not the
created.
Technology.
No, it's like the behavior and also the instruments that were built around that technology. And actually I found an article online a few days back that put it really well. And the article said, FTX was peak Wall Street, and by peak it's like peak oil. It was like, it couldn't be more Wall Street than that. What they meant is that no, it wasn't the technology, it wasn't the innovation that was brought in by Bitcoin that was wrong. It was like what happened around it. Because what people were really doing, and the reason why they lost their money, is not because they were doing Bitcoin transactions where everyone can see what is happening. We just discussed that, okay? They were giving their money to an entity using traditional like financial like systems, and they didn't know what was going on, because that's how like banking works. I trust my bank to do a good job, and if I'm telling my bank I'm giving this money to Frank, I trust the bank to record that on their ledger. What was happening with FTX is that they were giving their money, and they weren't even giving it to FTX, they were giving it to the other company, Alameda. And then what was happening, no one knew. And now we have found out that actually that money was mismanaged and was used for different purposes. That has nothing to do with the technology. Actually, the technology was created exactly to avoid that. But it wasn't fully...
It was fraudulent behavior,
Yes,
which
exactly.
has been around irrespective of which technology you're talking about. In this case, when you're saying they gave the money, I guess the way I understand it is really they sent fiat currency into a system which would then be trading in digital assets and cryptocurrencies. And that didn't happen properly.
Yeah, that is one thing that happened. The other one is that I think that also people that sent like cryptocurrencies lost their money, because again, in theory, if you do what we said before, you create your own address, you manage your wallet, and you put those transactions on the ledger, you actually know what is going on. What people actually did when they were transferring their cryptocurrencies into these accounts, and there are other examples out there, is that they were actually using web-based user interfaces where they were transferring this money, but they were not really creating their own addresses. What was happening is that their virtual money was bundled with other people's money in the same wallets, and so behind the scenes, these entities own the cryptographic keys of these like digital currencies, but you only had a web-based user interface where you had a balance, and there wasn't a real connection between your balance and a single unique address that was like tied to you. You were just part of a big bundle of like virtual money that was in the entity address. It could be easily mismanaged.
So it was, in a way, it was a bit of a hybrid of the old world.
Yes, exactly.
Of centralized
Yes.
finance control
Yes.
and potential manipulation, and new technology, which wasn't really done in the way it was supposed to be used.
Exactly, because to make it, like we said, it's really hard for people to manage their own addresses, and there is a lot of cryptography involved. So it was a good thing that some players in this space tried to make it easier for people. So they recreated these tools that people are used to using, which make it much easier to like have an account somewhere. I don't need to worry about losing my keys, and everything is on online all the time. But unfortunately, then either bad behavior from these service providers happened, or in some cases they were hacked. So there have been cases where, I mean, we see in the news, on this exchange, 500 million worth of Ether or whatever have been lost. That is not a flaw in the fundamental technology. What usually happens is that the systems that have been built around it to make it easier for people to use that technology have been compromised. So the money that gets stolen is because people get into those systems and then make those transfers to other accounts. But at the fundamental level, if everyone was managing their own keys, I mean, now Bitcoin has been around for more than 10 years. And I mean, you can imagine how many people must have tried, because there is a lot of value there, to kind of attack the system or try to find a weakness to...
It's been extremely solid.
Never, I mean, it has never failed. What has failed is the systems and the people around it.
So beyond digital assets and cryptocurrencies, because what we've now discussed, we've discussed really that area where we're talking about currency, cash, Bitcoin, the use cases that go beyond that sphere. So basically, beyond the aspect of replacing payment systems, maybe replacing fiat currencies. CORDA does a lot of, you have a lot of those types of projects. What what are the most interesting use cases that you know of, or that you're excited about, and that you feel like there should be much more talk maybe about those use cases rather than the FTX and the cryptocurrency part of the world, which obviously is in a bit of what they call a crypto winter right now because of the huge correction in value?
Yeah, so absolutely. But since you mentioned cryptocurrencies a few times, and now you also just said crypto winter, let me clarify what crypto is first, so that people don't associate us with crypto, or they don't or they maybe think that Bitcoin is all there is. So the blockchain technology underpinning Bitcoin is a piece of software, okay? And there are some parameters. For example, we just said that there is a cap on the number of Bitcoins that can be minted, which is 21 million. That is just a number in the configuration file, okay? So like when you fire up your PC and you change like the color of your web browser, okay? You pick a different color. So instead of 21 million, we can pick a different number. So what people did, they said, well, you know what? This is pretty cool. It's also open source, so anyone can download it. So let's tweak a few parameters, and now all of a sudden have a new version of Bitcoin. And I call it whatever I want, Frank coin or Bruno coin. That's how a lot of cryptocurrencies got started. Right. Some of them were just jokes, like Dogecoin. So now people are confused, because we started with Bitcoin because Bitcoin was trying to solve like something that was perceived as a problem, so potential control by central entities like governments. But now we have this plethora of cryptocurrencies. Well, I mean, what's the value? What's the usage? Why people are using them? What are they using for? Now, the sad reality is that 99.99% is just speculation. It's people that are hoping to get rich quick, because some have. So some people have made a lot of money because when people are starting to buy, I mean, when people saw that like Dogecoin, went like, I don't know, maybe it was 3,000x, I don't know, it was, some people made a lot of money. They bought the Lamborghinis and they put BTC or something like that on their license plates. So that attracted a lot of people that were just trying to get into this like get rich quick scheme. So a lot of crypto is just like that.
It's become a bit of a casino, which is now being cleaned out to some degree, which is healthy in a way.
Exactly. Also because if you think about it, you can't really buy, I mean, you can buy some stuff using Bitcoin, and that also has a very small penetration. I used to buy my soup.
Your soup?
Yes, using Bitcoin. Before the pandemic, there used to be a place not far from my office, so I would walk there. It was a 15-minute walk, and I would buy soup using Bitcoin. But again, it's very limited. And but with a lot of other like crypto, I mean, they are not accepted anywhere. So a lot of stuff is just useless, or is like a get rich quick scheme. Bitcoin, like I said, has a potential value as an alternative system. So the crypto winter is happening because, I mean, there's only so much money you can suck up from people. I mean, if you get on any if you go on the subreddit about cryptocurrencies, there are people that are really spending their savings on buying like fractions of whatever crypto of the day is, and there is
hoping to get rich quick.
Yes, there is only so much of that can happen. Okay, then we will run out. It's like a Ponzi scheme, really. Okay, so that just forget about that. That will go away over time. And so, plus in addition to that, there are all these bad actors like FTX and other people that are like using people money in inappropriate ways. So I think that again we will get past that and we will see the potential of these applications. So if we go back to this distributed ledger, so The fact that
maybe just before we go there, Bruno, it's interesting. I mean, we've not talked a lot about Bitcoin, but so if we look at the cryptocurrency and token world, like you said, a big part of it doesn't really have real use cases. Is gonna not survive. The ones that really are mentioned, obviously, most is Bitcoin and also Ether and Ethereum.
Yes.
It might be worth also explaining briefly, what that is, because to some degree I don't think people understand Ether and Ethereum.
Absolutely, that's a fantastic point that you bring up. So it's very simple to explain it. When blockchain was invented as the underpinning technology of Bitcoin, it did a simple thing. Miners will run a piece of code that was that simple code that transferred a Bitcoin or a fraction of Bitcoin from me to you, for example. So it's a very, very simple, tiny piece of code that does just that. This Bitcoin goes from A to B. So that is what the Bitcoin miners do when they, like we said, add these pages to the ledger. And then a guy thought, well, you know what, actually, why don't I make that tiny bit of code a bit more complex? Maybe that bit of code can do more than that. And I'm going to take that one step further. I can give people the option to provide me with that piece of code. So it's not going to be predetermined. It's not going to be the same for everyone. Let's do like this. Instead of broadcasting to the network this simple transaction and giving my Bitcoin to Frank, now I can broadcast any arbitrary piece of code. And so instead of moving money around, my piece of code can say, if on the 25th of December it is snowing in Zurich, then I'm going to play this music. It's a super stupid example, I know, but this is what is being called a smart contract, which basically means, okay, now when I broadcast that transaction, I broadcast this piece of code, so all the miners will have to run that piece of code, and then all those miners that are updating like the ledger with this new information, if when they run that piece of code, they verify that it's the 25th of November and in Zurich is snowing, then they will also execute another bit of that code, which makes something happen. So with these smart contracts now, you can create this software that is out there. It's kind of cast in stone. I mean, I broadcast it so everyone has the same copy, so we know that if someone changes just a little bit, that piece of the puzzle will be different from all the others, and we can easily say, okay, no, you're not participating in this anymore. And so we can have a smart contract that are executed automatically at the right time, that are verifiable, that can be changed, are immutable. And so there is a lot of value in it. They're not really smart because, like we saw, I mean, they do very simple operations, but although they're not smart, they're still very, very valuable. And that is what Ethereum is. So a very simple way to visualize it is that Bitcoin and blockchain is a big book with all these pages, is a ledger with transactions. Ethereum is a big computer. It's a huge, big, global distributed computer that can execute this tiny piece of software that go by the name of smart contracts. So it's like a major fundamental fork in the road. So we're talking about two very different applications and two very different use cases. So I think we got to a good place right now. So first of all, we got rid of all the cryptocurrencies, the stuff that isn't relevant because they're just Ponzi schemes. So we have left with only two fundamental, different technologies. One is a distributed ledger, which is only a ledger, so it records transactions. So it's good for creating digital cash, but also to represent assets using tokens and move that value around in transactions. And then there is the other technology, which is Ethereum, which is actually distributed computer, which again is like immutable, and it's a single source of truth. Whatever code gets run, we know that the outcome is what was determined by the creators of that software. Which is
what is the do the different nodes have to download Ethereum software on their computer? So is that how basically it's almost like an open source software that you have to run on all the computers that want to participate, right?
Yeah, basically all the miners will run the same version of code, which is what we as a user upload to the distributed.
Which then allows you to create yourself or deal in smart contracts created by others on that network, basically.
Yeah.
And the creation of those smart contracts, is that something which is difficult to do, or it sounds like it's actually quite simple code or software from what you're saying? Or is the programming of a smart contract something where you really have to be a programmer to do it?
Well, of course, it depends on who you ask, right? If you're a good software developer,
you'll say it's easy.
It's easy. If it's like maybe you and me, it's not like using an Excel spreadsheet, right? It's much more difficult.
Okay.
But it's fundamentally, it's simple software that does very simple things. So it's very powerful. The problem, and again, one attribute, which is that it is immutable, in a context can be good, in a different context can be bad. So what happened a few years back was that there was the first attempt at creating a distributed autonomous organization, a so-called DAO.
Yeah.
So a bunch of people got together with this idea, which was really cool. They said, you know what, you send us some like tokens, and then you get back, let's put it simple, you get a vote for every token that you send into this pool. And then we're going to vote what projects we want to fund. It was kind of a way of doing like a VC fund, something like that, okay? So people were contributing funds, and then they would get an option to vote for what projects would get funded. Okay. And it was all written in this smart contract so that no one could game the rules. There was one vote for one token that you had contributed. And then what happened right away is that people noticed that money started to leak out from this pool. What was that? And people started scratching their heads and said, and it turned out that there was a mistake that was made when the piece of software was created. And we know that software is buggy because whatever we use on our laptops, we know that we come across bugs every day. And what you do is go and fix it. You download an update from the internet and you fix it. But you can't do that.
You can't fix that because it's immutable.
Yes, by definition it's immutable. So there was an actor, and there is a reason why I'm not calling them bad actor. There was an actor that spotted that flaw in the code, and it was exploiting it, was using it to drain money from that pool into their own address. Now what happened next is even more interesting. People started going, oh, there is a hacker, we are being hacked, we need to try and do something. But there wasn't anything people could do. So the only thing that they came up with, which was actually really smart, I believe, they said the only way we can save this money if we all start draining money from this pool using the same mechanism and do it much more quickly than this bad actor.
So empty the pool.
Yes,
and then reinvest it.
Yes, let's try to empty the pool before he does it. Okay. And
so they teamed up, and that way they were quicker.
And it kind of worked. Yeah. But now, if you think about it, everyone was in a kind of a weird place because even if people found who that bad actor was, what do you think would have happened if they went to court with that?
They had no leverage because he didn't do anything wrong, because actually the code was the fault, was the problem.
Exactly. Yeah. He was using the code the way it was supposed to be.
You guys set the rules. I'm just using it as you said it should be used.
Actually. And if there were any doubt about that.
So did he really get away in the end?
Yes, yes. No.
Because it's not
sort of. So I get there. I get there. But so, yes, you got it right, 100%. So that's why I'm not calling it a bad actor, because in that within that context, yes, it wasn't mean like in our mind, it was doing something bad, but within that context, it was just playing by the rules, where the rules were wrong. To the extent that the only way for the other people to save some money was to play by the same rules. So if we got like in jail, then also the other people should have got in jail, because they were using the same exact mechanism to drain money from that pool. So what happened next is that, and it actually, in my opinion, was kind of the wrong decision to make. But anyways, the creator of Ethereum decided to go back in time. So basically, that is something fundamentally bad, in my opinion, because, again, it all is based on trust. Like, if the rules were that these smart contracts are immutable, we saw value in that. We bought into that vision. We created this. We made a mistake. But now, in order to fix it, they changed the software, the underlying software, to kind of neglect those transactions. And some people liked it because it allowed them to get their money back, but some other people said no, this is wrong.
It's, in a way, it's a form of censorship, right?
Yes, exactly. They said no, this is impossible, because if you do this now and you think you're doing it for like a good cause, how can we trust that in the future you're not going to do it again and again and again? So then what is the value of this?
It's Twitter, you're starting to take influence.
So there was what is called a fork. So some of the community said, no, we can't really ignore what happened, and we can't just pretend that it didn't happen. So we'll have to live with the consequences, but we will stick to the original vision. And so that became classic Ethereum. And then there was the other people that said, okay, no, we really want to get this money back. So we'll make this exception once. We'll change the rules for only this time. And that continued to be what is known as Ethereum. So now there are two competing technologies out there.
But both with the same name, or what's the name of
one is called classic Ethereum, which is the pure
Which camp is Vitali what's his name? Vitali.
Yes, he was the guy that created Ethereum, and he was the guy that said, okay, no, I need to...
He forked off.
Yes, and he said, no, I'm going to change.
So he's no longer in the classic camp now.
Yes,
he's in the
exactly.
Ethereum camp.
Yes, he's smart. He's a brilliant guy. He's done a lot of good work. But I'm one of the people that believe that there was a bad decision. Okay. So now, just for a second, think about the stuff that we're talking about. I mean, this is like science fiction. This is stuff that we didn't have 10 years ago. Well, yes, we already had it 10 years ago. But I mean, and the potential, the ramification, what we will do with this.
So help us, now we've been very technical and we've gone really, we had the first part, which was important, more philosophical cash, and then we've now been quite deep, into the detail a bit. So help us, trigger our fantasies of use cases that you see currently, for example, in your book of business with CORDA. What are the use cases that that people can think of to understand why we're excited about blockchain still? DLT being a tool and a technology that can solve a lot of issues down the road.
I'll give you some examples so I can get you a bit excited, but then I will explain why we should be way more excited than that, okay? So let's take it in two steps, and I will explain why. So, for example, in Japan, we have another application which is